Welcome back, Grade 6 to Nelson Math, Chapter 10, Getting Started. Chapter 10 continues our work with our numeracy. We are learning how to divide decimals. Our goals. We're going to be able to estimate the quotient when dividing a decimal. Quotient, as you recall, is the answer to a division problem. We'll be able to divide whole numbers and decimals by other whole numbers. We will use division and other operations to solve multi-step problems and solve problems by working backward. Let's do a little bit of review here. So this section here asks us to calculate using mental math and describe how you calculated just one of the answers. So let's solve these using mental math. For A, we're asking for 14.5 times 10. So this is the equivalent of saying 10 times of the 14.5. So add 14.5 10 times. We learn the pattern here, and that would be we are going to move all of our numbers to the numbers themselves in our place value chart are going to move to the left. So our 1 here, for example, which indicates 110, becomes a 100. And our 4, which is 4 ones, becomes 4 tens. And our 0.5, which is 5 tenths, becomes 5 ones. So our product is 145. We could also, of course, have just moved the decimal place over to the right by 1. That also works, or the place value method I just showed you. B, 14 divided by 10. So as our numbers get larger when we multiply by 10, our numbers get smaller when we divide by 10. And similarly, our numbers are going to be moving to the right. Each digit moves to the right. So this 1, which signifies 110, moves to the right 1, which becomes 1, 1. And our 4, which is 4 ones, moves to the right, so that becomes 4 tenths. So our answer is, our quotient is 1.4. And we can keep doing this as we move on. So 123.2, our numbers are going to get increased by a factor of 100. So our numbers, each digit will move to the left by 2. If it's multiplied by 10, it moves to the left by 1. But if it's multiplied by 100, it moves to the left by 2. So for example, this 100 here it goes from 100 to 1,000 to 10,000. So we're starting off with 10,000. So this number becomes 12,320. As you can tell, each of my digits here moved over to the left, and they each got bigger by moving over 2 columns in our place value like we talked about in the previous chapter. And as we move along, our 12.3, we're dividing it by 10, so that becomes 1.23. Our letter E, 1.5 times 1,000, we're moving all the digits over to the left by to 3 columns. So our 1 here, for example, which is 1, 1, that would end up being 1,000. So this would be 1,500. And lastly, 15.75 divided by 10, it's getting smaller, so it would be 1.575. I tended to use for this question, I used a lot of the place value chart. You are welcome to use the place value chart so that everything makes sense to you. Notice how all the digits are maintaining their same order. So in letter A, we have a 1 followed by a 4 followed by a 5. And here we have the same digits in the same order. The digits mean different things, but the order is always the same. Let's go on to the next question. Each group of boxes of blueberries has a total mass of 10 kilograms. The boxes in each group have equal masses. Estimate the mass in kilograms of each box of blueberries. So to recap, we have 3 boxes, but the 3 boxes together are 10 kilograms. So we solve this by saying 10 kilograms divided by 3. And for this, If we're estimating, we're going to choose friendly numbers. For my friendly number, I am going to choose 9. So I will round this off to 9 kilograms divided by 3. And for that, I'm going to estimate there are 3 kilograms in each one. But we can get even closer than that because I have an extra kilogram that I didn't calculate here. So I can even go further and say, well, what is 1 kilogram divided by 3? It's 1/3 of a kilogram. So I can say this is 3 kilograms and 1/3 of a kilogram, or 3 1/3 kilograms. Let's go on to the next one. We still have our total mass of 10 kilograms. However, this time we are dividing by 4 boxes. 1, 2, 3, 4. So if we divide by 4 boxes, we have a few different ways to estimate this. We could round our 10 kilograms to a friendly number, which could be, for example, 12 kilograms or 8 kilograms. But we can do better. Whenever we divide by 4, that's like dividing by 2 twice. So we can say 10 divided by 2 is 5, and then 5 divided by 2 is 2.5. So this is an exact answer. We're not estimating it, but it's an estimate and a calculation of 2.5, which we did mental math. And our last one, we still have 10 kilograms. And let's find out the number of boxes we have. We have two layers. We have a top layer, we have a bottom layer, and each layer has a 3 by 2 grid. So we have a 3 by 2, 6 on the top layer and 6 on the bottom layer. So that would be divided by 12 boxes. So we can once again round our numbers to 12 divided by 12. We could do that. And if we did round this to 12 divided by 12, I know I would be getting approximately 1 kilogram per box. However, I do know it would be a little bit less than 1 kilogram because I had to round up to get my friendly number. So it would be a little bit less than 1 kilogram. It could, for example, be about 0.8 or 0.9 kilograms. All of those answers would be valid estimates. As long as you were able to explain and you're able to justify what you are explaining, then everything is fine. Thanks, everyone. Have a good day.